Now, as you settle into the quiet space of your own breath, let your mind drift toward a world where entire oceans begin to rise from within. Tonight's tale invites you to rest inside a mystery as vast as the planet itself, a slow, synchronized awakening from the deep. Across the Pacific, Atlantic, and Indian Oceans, crystalline cities emerge from the seafloor, shedding ages of sediment like dream crumbs from an ancient memory. Their pale cyan lights pulse in the same calm rhythm once seen in the Antarctic vault, a heartbeat older than humanity. As these towers lift toward the open air, scientists like Catherine, Donovan, and Sophia begin to trace the quiet language beneath it all, the seabed machines feeding their corresponding cities, the once wandering trench structure sliding into perfect alignment below, and signals whispering through rock, water, and sky. You don't need to hold every detail now. Just let the idea of a planet gently rearranging itself float beside you as you drift towards sleep, a world changing not in violence, but in slow, luminous intention, inviting you to follow its rhythm into rest. Let's start from the very night when everything started, in the midnight over the Pacific. An old NOAA research ship floats in calm water, a dark shape against darker sky. The crew moves quietly. Most of the lights stay low to protect night vision. On the bridge, the glow of monitors paints faces in pale blue and green. In the sonar room, a technician leans forward. The sonar screen shows the usual shape of the ocean floor below them, a curved line of depth. It has looked the same for hours. Then, very slowly, a part of that line bends upward. Glitch, the technician mutters. He taps the side of the console. The line moves again. This time it rises in a smooth arc, a clean circle inside the curve of the seafloor. It is huge, tens of kilometers across, and it is climbing. He calls for the duty officer. They watch the data in silence. The new wall of seafloor rises at exactly 12 meters per hour. Not faster, not slower, perfectly steady, like a machine measure, not a natural event. High above, in orbit, Captain Eric Donovan sits in front of a different set of screens. His window shows a quiet curve of Earth, but his main focus is a thermal feed from the Pacific. A cold, flat patch of ocean suddenly lights up with thin lines of heat. They shoot outward in perfect circles, like a growing pattern on glass. Eric checks satellite health, sensor gain, calibration. Everything is normal. The ocean is not. At dawn, Earth's day side turns under the satellites, and more alerts arrive. Identical circles are rising in the Atlantic and Indian Oceans. Each structure climbs at the same 12 meters per hour. Each circle sheds gray sediment that falls like slow rain back into the deep. Underneath the falling mud and sand, something smooth and bright appears. In Washington, D.C., Dr. Catherine Moore stands over a table of holo displays at NOAA headquarters. She pulls in data from the ships, the orbital network, and the ocean floor grids. Numbers pour in: depth, diameter, density, rate of rise. Catherine builds a fast mass model, 3 platforms, each tens of kilometers wide, rising from the deep. She runs the simulation forward in time. A small change appears in Earth's rotation. Day length shifts in the 15th decimal place. Internal stress lines in the crust adjust by fractions of a percent. Tiny numbers, harmless in the short term, deadly over centuries. On the deck of a research vessel in the Pacific, Dr. Sofia Alvarez lifts night vision binoculars to her eyes. The sea ahead of her ship glows faintly. The top of the rising circle is just below the surface. Every few seconds, a pale cyan flash glints through the water, the exact shade Catherine remembers from old footage of the Antarctic vault under Lake Vostok. Back at her console, Catherine freezes the frame and calls up the Antarctic data. The match in color and rhythm is exact. Different ocean, same signal. Military channels come alive. Plans form. Missiles, depth charges, nets, massive anchors. But early tests bring a hard truth. Every tool passes through the rising walls as if through fog. No explosion, no impact mark, nothing. The platforms keep rising. Catherine watches the cyan pulse repeat across 3 oceans and understands the first clear fact. This is not a random event. It is a system turning back on, and nothing humanity owns can stop it by force. The first alert comes as a quiet red line on a screen. At 02:17 UTC, a deep-water buoy in the Central Pacific sends a strange depth reading to NOAA. The buoy is part of a global network, small floating stations that use sound to track the shape of the seafloor below. For years, its data has followed the same smooth pattern. Now the floor below it is rising. The change is tiny at first, a few meters, then a few more. The system flags it as a possible landslide. That is what usually pulls the seafloor up or down. Quakes, mud flows, slow slipping plates. The software tags it and sends it to the central servers. Minutes later, another alert arrives from the Atlantic, then the Indian Ocean. 3 separate buoys, each over different deep basins, report the same kind of rise, smooth, steady, and perfectly circular in shape. Catherine Moore walks into NOAA's main analysis room with a cup of coffee in hand. The large central display already shows 3 red boxes on a world map, blinking in the middle of wide blue oceans. "What are we looking at?" she asks. "Buoy anomalies," an analyst says. 3 locations. Depth change looks like a seafloor uplift, but the shape is wrong. Catherine's eyes narrow. "Show me the profiles." The wall display shifts to 3 stacked graphs. Each graph shows depth over time. The lines are smooth ramps, climbing at the same exact rate, 12 meters per hour. "Random landslides do not use a metronome," Catherine says. "Pull in sonar." They call up ship-based sonar sweeps from nearby research vessels and autonomous drones. Soft pings have been bouncing off those regions of seafloor for years. The baseline data is clear and stable. The new sonar scans arrive with a delay. On screen, the familiar outline of the deep ocean basin appears, a smooth bowl falling down to 5,000 meters. Then, inside that bowl, a new curve rises. "Enhance," Catherine says. The curve sharpens. It is not a rough hill or a broken slope. It is a perfect circle, tens of kilometers across, rising like a giant coin from the seafloor. The center is flat. The edges are smooth, almost vertical walls. "Is this some kind of data artifact?" someone asks. "Check 3 different systems," Catherine replies. "Different ships, different manufacturers. If all of them see it, it is real." They do. A NOAA survey ship in the Pacific, a European research vessel in the Atlantic, and an Indian Ocean climate drone all report. The same circular wall, the same rise rate, the same smooth surface. On the Pacific ship, Sofia Alvarez stands in the sonar room, watching the live feed. The operator runs the beam across the rising structure, tracing its outline. Mud and sand slide off its sides as it climbs. The sediment cracks, splits, and peels away in long sheets, like old paint falling from a clean surface. Underneath the falling sediment, the sonar return changes. The new surface is hard and sharp. It reflects sound in a strange way, giving brighter, crisper lines than bare rock. "Run a material profile," Sophia says. "It's not rock," the operator answers. "At least not any kind I've seen. The reflectivity is closer to crystal or some kind of dense ceramic." The same scene plays out in the Atlantic and Indian Oceans. Sediment that has lain still for ages now slides down in slow gray curtains. The water fills with plumes of dust as the circles rise. Autonomous submarines cut through those clouds, cameras pointed at the walls. At first, all they see is mud, but as the walls climb closer to the surface, currents strip more sediment away. Long vertical shapes appear. Towers, at least 50 meters across, set along the circular wall at even intervals. Each tower has deep channels carved into its sides, like gutters on a building, leading from the base up to the flat top. "Freeze that frame," Sophia says into her mic, watching from the Pacific ship as a drone sends back high-resolution images. Zoom in on the channels. The enhanced image shows smooth interfaces with no chips or cracks, as if carved yesterday. The edges are sharp, too sharp for something that has sat under kilometers of water and silt for thousands of years. "It looks new," the drone pilot says quietly. In orbit, Captain Eric Donovan receives a priority link from NOAA. A feed from his thermal satellite shifts to the first Pacific location. At normal settings, the ocean's surface looks even and dark. He adjusts the range. Thin lines appear. Run high sensitivity, he tells the system. The lines brighten. They run out from a hidden center to the surface in straight paths, then bend, following the rising circular wall. Heat is flowing from deep below, not in random patches like volcanic vents, but in ordered paths, like power cables. Eric checks the timestamps. The heat pattern grows in perfect sync with the measured rise, 12 meters per hour, every hour. The control board signals another alert. The same pattern is now visible in the Atlantic, then the Indian Ocean. 3 glowing circles grow on his thermal map of Earth, like 3 rising gears in a huge machine. He switches to radar altimetry, satellites that measure tiny changes in sea surface height. The water above each rising circle bulges upward by a few centimeters, pushed by the mass lifting below. The bulges are round and smooth, as clear as a ring in a still pond. Sending full packet to NOAA now, Eric says. This is coordinated. Back at NOAA, Catherine stands between floating displays of sonar, thermal maps, and radar height graphs. She draws a virtual line around the 3 circles on the globe. Pacific, Atlantic, Indian. Different depths, different tectonic plates, exact same behavior. Check the orbital surveillance network logs, she says. Have these areas shown any change in the last decade? Microquakes, thermal drift, gas plumes. Analysts pull up 10 years of history. The regions have been quiet. No known volcanoes, no recent quakes, no oil or gas seeps. Then these did not grow, Catherine says. They were already there. They just started moving. Sophia's live video from the Pacific comes up next to her. The falling sediment now reveals more detail. Horizontal walkways between towers, radial channels across the flat center, all arranged in precise geometry, circles within circles, lines meeting at steady angles. This is city geometry, Sophia says into the shared channel. Streets, platforms, access ways. This is not a random rock dome. We are calling them platforms for now, Catherine says softly. But yes, I see the same thing. As the platforms rise past 3,000 meters depth, water pressure drops slightly, and more mud slips free. Cameras finally catch direct light, reflecting off the surfaces. They shine with a pale, glassy look. The color is not clear stone, not metal. It is a faint, cool blue that seems to hold its own tone even in the deep dark. Catherine pulls old files from her personal archive. She overlays an image from the Antarctic vault under Lake Vostok, crystal columns in a hidden chamber, glowing with a pale cyan light. She places it next to the new shots from the ocean platforms. Same color, same clean lines. Same strange sense of perfection. Can we match the rise rate to anything natural? An assistant asks. Catherine shakes her head. Natural uplift comes in bursts tied to quakes or slow plate motion. This is constant, 12 meters per hour in all 3 oceans. You do not get that kind of sync by accident. Eric confirms from orbit. I have timing down to the second. Pacific, Atlantic, Indian, all started within a 1-minute window. And the slope of the rise is identical. Someone turned something on, Sophia says quietly. Catherine does not answer. She calls up a map of global tectonic lines. She overlays the positions of the 3 rising platforms. All 3 sit flush on major plate boundaries, where Earth's crust slips and grinds. She adds in older data from the seabed, machines, those strange devices buried along tectonic lines that had woken months before, sending power surges toward the Antarctic vault. The red dots of those machines form long chains under the oceans. When she zooms out, a pattern starts to appear. Lines of machines running under the plates, rising circles sitting at key junction points, like hubs in a network. These are nodes, Catherine says. The seabed machines are like wires. The platforms are like stations. This is a system, global, designed. Her words travel through the link to Eric and Sophia. For a moment, no one speaks. Outside Sophia's ship, the water grows brighter. Bioluminescent plankton swirl as they react to the slow change in temperature and chemistry. The top of the Pacific platform is now less than 1,000 meters below the surface. Send a drone straight down the central axis. Sophia orders. I want to look at the crown. The drone drops through dark water, lights on low. As it nears the peak of the rising circle, the sediment thins. The central area comes into view, a wide, flat disk, etched with concentric rings and radial trenches that all meet in the exact center. In that center, set into the floor, is a cluster of tall, smooth spires. They are crystal, just like the Antarctic columns. They do not glow yet, but they reflect the drone's lights in faint cyan tones. Sophia sends the feed to Catherine. These are cores, same style as Vostok. Catherine zooms in, measuring angles and spacing. The cores are placed with perfect symmetry. Their bases sit in deep sockets, with channels leading outward like veins. Eric, Catherine says, compare the layout to the thermal lines you're seeing from orbit. Eric overlays his heat map with the structural photo. The warm paths run exactly along the engraved channels, and all point straight at the central spires. It's a power grid, he says. Whatever is rising is being fed from below, through the tectonic lines. The ocean floor machines started this, and these platforms are taking that energy. Catherine steps back and looks at the global view again. 3 circles, dozens of power lines, a known vault in Antarctica, a moving trench city in the Pacific that has been behaving strangely for months. These platforms are not alone, she says. They are part of a much larger design, and it is turning itself back on whether we understand it or not. Outside, under thousands of meters of water, the 3 circles keep climbing, 12 meters per hour. Every hour, perfect, steady geometry, rising toward light. Chapter 2. A planet begins to tilt. By the 3rd day, the platforms have climbed hundreds of meters. They are still far below the surface, but the mass they move is enough for Catherine to do more than guess. She stands at a large interactive globe, Earth spinning slowly before her. Around it, rings of numbers show rotation speed, day length, and internal stress factors. Small arrows point along fault lines, showing how force moves through the crust. Give me total mass estimate per platform, she says. An assistant pulls in sonar, density scans, and gravitational field shifts measured from orbit. The system runs a fast model. Each structure is roughly 60 kilometers in diameter, the assistant says. Thickness unknown, but we have a lower bound from current height. Estimated mass per platform, about 10 trillion metric tons. Catherine nods. 3 platforms, 30 trillion tons moving closer to Earth's axis. She taps the globe, zooming into a simple model. A white ring appears, representing the platform's average distance from the planet's center when they were at rest on the seafloor. Another ring appears slightly closer to the center, showing their new position at a higher level. Think of a spinning figure skater, she says to the room. Arms out, spin is slower. Arms pulled in, spin is faster. Earth is the skater. These platforms are the arms. She drags the platform's ring slightly inward. A small number at the side of the globe. Updates. Length of day. It shifts in the last few decimal places. Right now the change is tiny, she says. We are talking microseconds, added or removed from a day. No one will notice, but this is just the start. A graph appears behind her, showing platform height over time. The line rises straight and smooth. At the right edge, a dotted line extends forward, showing where they will be in weeks and months, if nothing stops them. If they keep rising at 12 meters per hour, she goes on, their mass will shift upward by several kilometers. That changes Earth's rotational inertia, not by much in everyday terms, but enough to alter how stress builds in the crust over decades, even centuries. She touches another control. A simple animation appears, a spinning ball with little arrows representing forces inside. As the platforms move upward in the model, the arrows shift, concentrating more stress along certain fault lines, easing it along others. This is not about tomorrow's weather, she says. It is about patterns, where quakes will be stronger, where volcanoes will be more likely, how ocean currents might adjust to a slightly different spin. Climate is a long story, and we may be changing a line of that story without consent. In orbit, Eric checks her model against incoming sensor data. Tiny changes in Earth's gravity field, measured by twin satellites, match the predicted mass shift. Laser ranging to the moon shows the slightest phase change in its orbit, as if the dance between Earth and Moon has changed tempo by a whisper. Your numbers are solid, he tells Catherine over the link. Grace 3 confirms the mass redistribution. The wobble in Earth's axis is still within normal noise, but the trend is there. Below, reactions begin. At first, governments treat the platforms like any new ocean hazard. They issue notices to shipping lanes, warning vessels to avoid certain coordinates. Research funding shifts overnight. Naval fleets move closer, partly to learn, partly to guard. Then the first military tests begin. In the Pacific, a submarine moves into position beneath the rising circle, staying just outside the falling sediment. It lines up several torpedoes, set to detonate along the wall. Fire, comes the command. The torpedoes race through the dark water, leave bright trails on sonar, and hit the wall dead center. Or they should. Instead, on sonar, the torpedo tracks pass right through the measured position of the wall, as if through empty water. There is no blast, no shockwave. Instruments feel nothing. On the surface, a destroyer launches a depth charge set to explode just above the platform edge. The ship's crew waits for the dull, heavy thump to roll through the hull. Silence. The charge goes off far below, but it does not couple with the structure in any way. There is no visible mark on the wall, no crack, no crater. Viewers see bubbles and debris swirl in open water, but the smooth surface of the platform remains unchanged. Run the footage again, a Navy officer says. Slow it down. They replay the launch and impact paths frame by frame. The virtual markers for the weapons pass through the same space the wall occupies. It is like the wall is not there, someone says. But it is, Sophia replies from her ship. Our sonar sees it. Our drones hit it if they try to land. We can touch it with instruments at close range. The phase field is only active against high-force external attacks. The term phase-shifted structural field moves from classified notes into shared science documents. Analysts describe it in simple terms. The structures are slightly out of step with normal matter at certain energy levels. Gentle contact works. Fast, violent energy passes through, as if the timing is off. If you slap the wall, your hand goes through, Sophia says in a briefing. If you press your hand slowly, you feel solid crystal. Engineers attempt a different approach. Massive anchor cables are dropped from ships. Hooks spread wide to catch on any part of the rising geometry. The cables tighten as the platforms move, then pass straight through the walls and towers as if they snagged fog. No matter the trick, explosives, lasers from orbit, focused microwaves, the result is the same. The platforms ignore the attacks. Their rise speed does not change by even a fraction of a percent. They are untouchable to brute force, Eric says to Catherine. At least with tech we have now. Catherine adjusts her models again, this time adding the fact that humans cannot stop the vertical motion. She pushes the simulation out 100 years. Day length changes by milliseconds. Earth's tilt shifts slightly as the planet seeks a new balance. Wind bands creep a little north here, a little south there. Ocean currents bend, feeding more heat to some regions and starving others. On a large screen, she shows a simple before and after of global storm tracks. In the after image, some familiar storm paths weaken. Others grow stronger as warm water pools in new places. Humans like to think in election cycles. She tells a joint meeting of UN science advisors and military leaders. 4 years, 8 years, maybe 20. The platforms are not on that cycle. They think in centuries, maybe longer. But our grandchildren and their children will live in the world these things are shaping right now. A general asks, "Are you saying this is a weapon?" "No," Catherine answers, "at least not in the way we use that word. These platforms are adjusting the planet. That could help long-term stability or harm it. We do not know the target state they are aiming for. Policy debates start soon after. Some leaders call for more force, more weapons, new research into ways to break the phase fields. Others argue that any attempt to damage the system could cause worse outcomes, partial failures, unstable jumps in stress, sudden quakes. On the streets of coastal cities, people react in slower, simpler ways. In San Francisco, parents watch news feeds showing the rising platforms and quietly update their long-term plans. In Mumbai, Small business owners near the sea check new flood maps and see that future storm surges might go around them or straight through them, depending on how currents shift. Governments begin orderly precautionary movements, a polite term for early quiet evacuations. They do not call them that in public. Officially, these are infrastructure upgrades and planned resettlement initiatives. But the effect is clear. Coastal populations in the most vulnerable zones start to thin. Satellite images show slow changes. Shipping routes bending away from the rising circles. New temporary ports built farther inland. Emergency stockpiles growing in highland warehouses. In a live TV interview, a host asks Catherine, "Should people be afraid?" She thinks before answering. "Fear does not help us think clearly," she says. "The platforms are rising no matter how we feel about them. Our best response is to understand. The more we know, the more we may be able to predict, or even influence what comes next." "Influence how?" the host presses. "We just watched missiles pass through them like smoke." "Not with force," Catherine says. "With information, signals." The Antarctic vault woke when it heard a pattern in a human heartbeat. These platforms share that same pale cyan pulse. That is not a random link. If this is a network, then it listens as well as acts. The host looks confused. "You are saying we should talk to them?" "I am saying our only chance may be to learn their language," Catherine answers. "Right now the platforms are moving mass in a way that will tilt our planet's future. They are doing it according to rules we do not yet understand. If we stay ignorant, we live with whatever they decide. If we learn to speak even a little, we might have a voice in that decision." Far at sea, Sophia watches the Pacific platform climb. Its crown is now less than 500 meters below the surface. The pale cyan pulse has begun, faint at first, then stronger, beating at a steady rate that matches old recordings from Lake Vostok. She records the pattern and sends it to Catherine and Eric. In orbit, Eric overlays it on electromagnetic readings and finds matching spikes in radio bands and low-frequency magnetic waves. "It is not just light," he says. "It is a full signal packet." Catherine receives the files and loads them next to Naomi's past heartbeat data, the signal that woke the Antarctic vault. The match is not in the exact shape, but in the structure, a bass rhythm with layered harmonics, shifts tied to feedback from the environment. "These platforms are not just mass," she says. "They are part of a control system. They are changing the planet while talking to each other and to the machines below." She looks up at the global model again. The platforms keep rising. The numbers keep drifting. If nothing changes, Earth will settle into a new balance over hundreds of years, guided by rules written by a civilization that vanished long before humans learned to write. For the first time in her career, Catherine feels that her job is not to stop a process or even fully predict it, but to join a conversation already in progress. Outside, across 3 great oceans, the circles climb and glow, and a very old plan begins to tilt a young civilization's world. Chapter 3. Signal Architect. The Pacific was never truly still, but lately the water felt tense. On the deck of her research ship, Sofia Alvarez watched the horizon. Far ahead, the ocean rose in a long, low swell, where the platform climbed beneath. It was like a slow-growing island that had not yet broken the surface. She pulled her hood tighter against the wind and checked her tablet. Power flow maps overlaid the Pacific, bright lines running along tectonic plates like glowing seams. At each bright spot, a seabed machine pushed energy into the crust. Catherine's voice came through the earpiece. "Sophia, I have the new surge data. Ready to compare?" "Send it," Sophia said. "I'm tied to the grid model now." In Noé's war room, Catherine stood in front of a different map. Her screen showed the whole planet. Thick white lines for tectonic plates, red dots for seabed machines, blue circles for the 3 rising cities. She sent her latest analysis to Sophia and to Eric in orbit. "Okay," Catherine said on the shared channel. "Here is what we know. The seabed machines spike in power before each rise jump in the platforms. Not random, not local. It's coordinated." On Sophia's tablet, colored lines updated. The Pacific plate lit up first. Red dots along the plate boundary brightened in sequence, marching like a wave toward the center of the ocean. At the end of that wave sat the Pacific platform, So the seabed machines fire in order, Sophia said, tracing the line with her finger. Each one passes charge to the next, until the flow hits the base of the city. Exactly, Catherine replied. Imagine a long row of people passing buckets of water down a line to fill a big tank. The tank is the platform. The people are the seabed machines along the plates. Eric added his view from orbit. High above Earth, his satellite network watched small changes in heat, gravity, and magnetism. I can confirm that, Eric said. Grace 3 sees slight gravity changes moving along the plates just before each surge. It's like watching a power wave travel through the crust. He tapped a control on his screen. A bright curve of energy ran under the Pacific, then split into branches, then merged again near the center where the platform rose. And it's not just the Pacific, he went on. Same thing in the Indian and Atlantic. Each ocean has its own highway of machines feeding its own city. So the saying is right, Sophia said. The Pacific machines are feeding the Pacific city. The Indian Ocean machines are feeding the Indian city, and so on. Catherine zoomed her view out and overlaid more data. Months of recordings showed pulses from the seabed machines, spikes in the Antarctic vault, and the timing of Naomi's old heartbeat event. When she aligned them by time and shifted for delay through rock and water, a picture began to form. The vault was never alone, she said quietly. It was a central hub, listening to this entire network. When Naomi's heartbeat matched its pattern, it woke earlier than planned. That wake-up echoed through all of this. Sophia caught herself before using the banned word for that rebound. Triggered, she said instead. You're saying Naomi's triggered a full system check? Yes, Catherine replied. The vault sensed a familiar rhythm. It responded. That action sent a signal down the lines to the seabed machines, and now those machines are powering these cities. On the main wall in Noah, she called up the old Vostok vault footage. Pale cyan columns glowed in the dark ice chamber, pulsing in sync with Naomi's slowed heartbeat. Next to it, she put a live feed from nightside satellites over the three oceans. From space, each rising city now showed as a wide, smooth disk just below the surface. At night, faint cyan crowns glowed at their centers. Each pulse matched to the Antarctic color and timing. Eric watched from his orbit track and pulled the data himself. He measured the pulse period, 2.7 seconds bright, 2.7 seconds dim, then a short flicker. Then the cycle repeated. Antarctic vault pulse, 2.7 seconds bright, 2.7 seconds dim. Short flicker, he said. Rising cities' crowns, same base period. Small differences on top, but the skeleton is identical. Sophia leaned on the rail and looked out across the water, even though she knew she could not see the glow with her eyes. They're all talking on the same channel, she said. Vault, seabed machines, cities, same language family. Catherine smiled a little at that. Signal language, she said. We finally have enough data to start calling it that. She grabbed a stylus and began drawing on the holo display. Simple blocks for structures, arrows for energy flow. Here's how it lines up, she said. Tectonic plates move and store energy. Seabed machines sit along the lines where plates meet and grind. They eat that energy and shape it like little power stations. They send the shaped power along the plate toward key hubs. Those hubs are the cities, and at the center, coordinating it all, is the Antarctic vault. Eric added electromagnetic plots to the mix. Each cyan pulse was not just light. It carried faint radio, low-frequency magnetic waves, and tiny sharp spikes the instruments barely caught. The cyan pulse is like a carrier wave, he said. On top of it sits a pattern signal. The pattern changes as the environment changes. Stress, temperature, even solar wind. So the network is not just pushing power, Catherine said. It is also sharing status. Every city and machine is telling the others what it feels. Sophia checked the latest readings from her ship. Did you see the last quake in the Solomon Islands? She asked. Magnitude 6.4. No damage, small tsunami. But look at the timing. She sent the data packet. A graph appeared on Catherine's wall. Quake time in red. Network pulse shifts in blue. 3 seconds before the quake, nearby seabed machines flicked to a different pattern. Shorter bursts, higher intensity. The Pacific platform's crown dimmed for one cycle, then resumed at a slightly changed rhythm. They felt the stress build and adjusted, Sophia said, either to reduce it or to use it. Catherine drew a line from the quake zone to the nearest seabed machines, then up to the city hub. This network is like a second nervous system for Earth, she said. The crust is the body. The tectonic lines are nerves. The seabed machines are relay points. The cities are big processing centers. The vault is the brainstem. And right now that nervous system is waking up, Eric added. It is starting to move muscles we thought were just dead rock. A new alert appeared on Eric's console. A submarine patrol in the Pacific had filed a sealed report. He had clearance to see it now. Hold that thought, he said. We have fresh data from the moving trench city. The phrase still made Catherine's jaw tighten. The first Lemurian structure humans had found had also been the strangest. It had sat in a deep trench in the Pacific, hard to map, always shifting position when scanned. Some people joked it was shy. Eric opened the report. Sonar maps from the last month scrolled past. At first, the trench city jumped around within a few kilometers whenever active sonar hit. Sometimes it appeared tilted, sometimes straight. After the Antarctic vault event, its jumps had slowed. Now in the most recent frames, the structure had stopped jumping at all. Sending now, Eric said. Catherine enlarged the new map on her wall. A narrow trench, thousands of meters deep, cut across the seafloor. In that trench sat a long, curved structure, like part of a circle. Before, its shape never lined up the same way twice. Now it had settled into a fixed orientation. She overlaid the position of the rising Pacific surface city. Her breath caught. The trench city lay almost exactly below the platform, just offset by a few kilometers. A dotted line from the platform's center dropped straight down toward it. Give me precise coordinates, she said quickly. Her assistant read off the numbers. She fed them into the alignment model. The system rotated the trench city slightly, assumed a full circle from the visible curve, and projected the match. The result lit up her screen. If the trench city rises or the surface city lowers, she said, they would interlock like two gears. The center of the trench ring lines up under the central crown of the platform. Sophia received the same overlay on her tablet. She sat down hard on a storage crate. So the moving trench city wasn't wandering, Sophia said. It was searching, looking for the right place to park under its surface partner. Like a docking maneuver, Eric said. It drifted until the network told it where to stop. Now it's locked in under the Pacific city, waiting. Catherine called up time-lapse data of the trench city's motion over the past year. At first, the trail looked like a random squiggle in the trench. Then, as months passed and the Antarctic vault woke, the motion slowed and curved toward the spot under the platform. It homed in on the city's base, she said softly. These things were built to match up. Deep structures below, surface platforms above. She pulled out to the global view again. The picture grew more complex. Seabed machines along tectonic lines fed energy to both the trench city and the rising platform. The trench city now sat in a perfect spot to connect vertical shafts up into the platform's underside. The trench city is not a city at all, she said, or not only a city. It is a connector, a plug. It joins the deep grid to the surface grid. Sophia nodded slowly. So each ocean may have a set, a deep city anchored in a trench and a surface city above. The seabed machines link them to the plates. The vault ties them all together. Eric added magnetometer readings. There's more. The magnetic field lines above the Pacific have started to bend slightly toward the platform area. Not much, but enough to see. It's like the network is shaping not just geological energy, but magnetic flow as well. Plates, oceans, magnetism, Catherine said. It's all connected. The Lemurians didn't just build cities. They built a second skin for the whole planet. Data from the Indian Ocean came in next. While there was no known moving trench city there yet, odd reflections had begun to show up in a deep basin, partial arcs, faint and hard to map. The Indian system may be behind the Pacific in its schedule, Catherine said, but the pattern fits. Machines on the lines, a rising surface city, and something hiding deep that is starting to stir. In the Atlantic, a quiet but steady hum built along the mid-Atlantic ridge. Seabed machines there pulsed in long, regular beats. The Atlantic city's cyan crown matched that tempo now, sinking more closely every day. Catherine drew a simple chart, 3 rows, 3 oceans. Columns for deep structure, surface city, seabed machines, vault link, pulse pattern. In the Pacific row, every box was filled. Deep structure, moving trench city, now aligned. Surface city, rising cyan crown active. Seabed machines, lit along ring of fire. Vault link, strong with direct pulse matches. Pulse pattern, adaptive, reacts to quakes. In the Indian row, 3 boxes glowed. Deep structure, partial hints. Weak, surface city, rising, crown active. Seabed machines, lit along plate edges. Vault link, medium. Pulse pattern, simpler. The Atlantic row showed a similar mix. We're watching a system finish booting up, Eric said. Pacific first, then the others. On Sophia's ship, the science team gathered around her screen. If the trench city and surface city really dock, a younger researcher said, what happens then? We do not know, Sophia answered honestly. But the power flow will be much stronger. Right now they are like loose wires held near each other. Once they touch, the circuit closes. Catherine listened and stared at her global model, her mind jumping ahead. A closed circuit meant bigger changes, stronger control over stress release, ocean chemistry, even air movement. It also means the network's real behavior has not started yet, she said. So far, we have only seen the warm-up. She thought of Naomi in the Antarctic vault, heart slowed to match ancient crystal, breath shallow and weak while the columns came to life. Something about that human link had given the system a reason to wake. The vault reacted to a human signal, Catherine said. That means this network can hear us. It can add new input to its patterns. That may be our path. She highlighted the pale cyan pulse shared by vault and crowns. This is the key, she said. The same color, same base rhythm, from Antarctica to the Pacific, to the Atlantic, to the Indian. The seabed machines carry that timing through the crust. The trench city under the Pacific follows it now. There is a language here, rules, grammar. If we crack even part of it, we might shape how the network docks and what it does after. And if we do nothing? Eric asked. Then the Lemurian design runs without us, Catherine replied. The deep cities and surface cities lock together. The plates, oceans, and fields shift into the layout they wanted millions of years ago. Maybe that state is stable and safe. Maybe it is not, but it will not be ours to choose. Sophia looked out over the dark Pacific again. Somewhere under that moving skin of water, an ancient city slowly slid into place under another, like a key turning in a hidden lock. She tightened her grip on the rail. Then we better learn to talk fast, she said, before the system finishes talking to itself and decides what kind of world it wants to make. Chapter 4. Threshold of a Second Earth. The first test was small on purpose. In a sealed lab at NOAA, far from any coast, a cluster of servers hummed around Catherine Moore. On the main screen, waves of pale cyan scrolled left to right, recordings from the Antarctic vault, from the rising city crowns, from seabed machines. Naomi's heartbeat pattern sat on a separate track. Below, a simple line of spikes, slowed and shaped by the drugs she had taken under Lake Vostok. Sophia watched from the Pacific ship on a wall display. Eric watched from orbit on his console. Let's go through this once more, Catherine said. We know that when Naomi's heartbeat matched the vault's base rhythm, the vault woke, the columns lit. Signals ran down the tectonic lines to the seabed machines. Now the machines are feeding power to the cities. She pointed at the stacked tracks of data. The vault and the cities share a base pulse. 2.7 seconds bright, 2.7 seconds dim, short flicker. On top of that, both carry extra patterns that change with stress and environment. Our idea is simple. We will not try to control the whole language. We will just copy the base greeting and shape it slightly, then send it back into the grid at low power. Like saying hello, but with a small question attached, Sophia said. Exactly, Catherine replied. We will not shout. We will knock. Eric double-checked the transmission plan. And you're routing this through the safest point? He asked. Yes, Catherine said. We picked a stable section of the Pacific Plate with few faults, away from any city and far from the rising platform. If our signal is ignored, nothing happens. If it is heard and misunderstood, any local stress change will be tiny. On Sophia's ship, engineers had lowered a heavy transmitter cage to the seafloor days before. It sat next to a known seabed machine, close enough to share the same rock volume but not touching. Underwater cameras showed the machine, a low dome half buried in sediment, smooth and pale, with faint cyan lines crawling over its surface. This machine has been pulsing at a steady low rate, Sophia said. It's like a quiet heartbeat. We are going to talk next to it and see if its rhythm changes. Catherine took a breath. Okay, phase 1, pure copy. She loaded a file that held a perfect sample of the base vault pulse. No extra spikes, no added structure, just 2.7 up, 2.7 down. Flicker. She converted it into a low-frequency acoustic and magnetic signal that the transmitter could push into the rock. Eric, are you ready to watch from orbit? She asked. Already watching, he said. I have thermal, gravity, and magnetics locked on your test zone. If anything burps, I'll see it. Good. Sophia. Transmitter is armed and synced, Sophia replied. We're at 1% of the seabed machine's normal output. Very gentle. Catherine nodded to the tech. Start the loop. On the seafloor, the transmitter cage came to life. No light showed, but instruments marked a soft wave of sound and a ripple of magnetic change moving into the crust. For 5 minutes, they sent the pure base pulse. Nothing else changed. The seabed machine beside the cage went on at its usual slow beat. The Pacific platform's cyan crown, thousands of kilometers away, kept its old rhythm. The Antarctic vault, still mostly quiet under ice since Naomi's event, showed no new glow on its sensors. They're ignoring us, Sophia said after the 5th minute. Good, Catherine answered. That means we're not making trouble. Phase 2. She pulled up Naomi's pattern and laid it over the base pulse, like a faint guide. Then she removed the small parts that had caused the vault to spike hard before the sharp jumps when Naomi's heart had stumbled. What are you doing? Eric asked. Building a softer version of the same hello Naomi gave, Catherine said. Slower rise, no sudden jumps. We want the network to notice us, not think someone is dying in its arms. The new signal looked like a smooth wave riding on top of the bass rhythm, a little more complex than before, but still simple. We'll push this at 2% power, Sophia said, still safe. The text loaded the new file. On the shared channel, everyone watched the graphs. Begin phase 2, Catherine said. The transmitter's pattern changed. In the lab, the cyan trace now had a slight wobble. On the seafloor, the cage sent that wobble into the rock. For 30 seconds, nothing happened. Then, very slowly, the nearby seabed machine's own pulse shifted. Hold on, Sophia said, eyes wide. Look at channel 3. The machine, which had kept a steady gap between its pulses for weeks, shortened that gap by a fraction of a second. Its brightness in the cyan band ticked up a hair. It was small, but clear. It heard us, Catherine said quietly, and it responded. It did not spike or shut down. It tuned itself a little closer to our pattern. Eric saw something from above. Magnetics above your test point just twitched, he said. Very small, but in sync with that change. The machine is feeding your greeting into the larger grid. Sophia's team cheered, but she raised a hand. Easy. We do not know if this is good attention or bad attention. Catherine grinned, the first real smile in days. It is attention. That's enough for now. Cut the signal. The transmitter went dark. The seabed machine slowly drifted back to its old rhythm over the next 10 minutes, like a person going back to rest after a short conversation. No quakes, Eric reported. No stress jumps. Just a tiny blip in the local field. Perfect, Catherine said. We have proof. The grid hears and can be nudged by simple signals. Over the next week, they ran dozens of tests. They tried tiny delays, tiny speed-ups, little questions in the pattern, short double flickers, longer holds. They never pushed more than a few % of the machine's normal power. They always watched stress maps with care. Bit by bit, a crude map of yes and no grew. Send a double flicker at the end of a cycle. The seabed machine brightened its own end flicker in reply. Send a long, flat hold in the middle. The machine sharpened its own middle spike, as if pushing back. Change the base period from 2.7 seconds to 2.6. Nothing. From 2.7 to 2.8. The machine dimmed briefly, then reset as if refusing that timing. They're picky about the base period, Catherine said, staring at the chart. 2.7 seems locked, but there's room to move above it, in the little shapes we add, and when we push too far, they just ignore us or bounce back to default, Sophia said. They have guards. During one test, they sent a mild slowdown pattern, longer gaps between peaks, into a machine that fed a small local energy line. For several minutes, the pulses down that line did in fact lengthen by a hair. At the same time, the tiny rise rate of a nearby seamount, which sensors had been tracking, dropped by 0.1%. It's very small, Eric said, looking at his graphs, but I think you just slightly slowed uplift in that patch of crust. As a proof of concept, that's huge, Catherine said. We're not just chatting, we're shaping a result, even if it's small and local. With each test, their crude signal language grew. They still understood only a thin slice of it, like a tourist with a phrase book. But it was enough to say, I am here, do you hear me? And sometimes, please ease this a bit. As they learned, their view of the Lemurian system changed from a pile of strange machines to something more, like a designed shell around Earth. Catherine began to call it the second layer. In a global briefing, she brought up a cutaway model of Earth: inner core, outer core, mantle, crust. Then she added another semi-transparent layer around the crust, a web of lines, nodes and disks. This is the Lemurian network. As far as we know, she said to leaders and scientists across dozens of nations. Seabed machines on tectonic lines, deep trench cities, surface platforms, and the Antarctic Vault. Together they form an added shell around our natural planet. She touched different parts of the model as she spoke. The seabed machines shape how stress and heat move through the plates. They can change where quakes release and how often. The deep cities and trenches sit at points where plates dive or pull apart, controlling deep flows. The surface cities add mass and structure above the oceans, affecting rotation and sea movement. The model lit up in soft cyan, pulsing like a slow heart. This shell is not just physical, she went on. It carries information. Signals pass through it all the time, sharing the state of the planet. In a sense, the Lemurians gave Earth a second mind, an added control layer that sits on top of its normal physics. A leader from a low-lying island nation leaned forward on her screen. Why would they do this? She asked. What did they want? Catherine did not pretend to know for sure. Maybe they saw long cycles of climate swings and plate shifts, she said. Ice ages, superquakes, flood basalts. Over millions of years, those swings can wipe out whole branches of life. Perhaps they wanted to smooth the ride, spread out the stress, guide sea levels gently, instead of in huge jumps. Or they wanted the planet tuned for themselves, a security advisor said. Their comfort, their needs, not ours. That is also possible, Catherine said. We do not know their motives, but we can see the function. This is climate and tectonic management on a timescale far longer than our history. She hesitated before adding the last part. And maybe, she said, it is not just about rock and water. The Antarctic Vault responded strongly to a human heartbeat. The signals it sent through the network carried patterns that looked like feedback, like learning. It is not crazy to think they were also guiding something less physical, perhaps how complex minds arise and grow. You are saying they might have designed this to shape consciousness? The island leader asked. I am saying they might have cared about how intelligent life thinks and feels, not just where continents sit, Catherine replied. But that part is guesswork. All we really know is that this network can hear a human and adjust when it finds a match. In orbit, Eric pulled up long-term field data. Whatever their reason, the second layer is waking, he said. The three cities are almost at first stage height. The Pacific Trench City is lined up under its platform. Magnetics are bending. Stress is redistributing. A new balance is coming. On the Pacific ship, Sophia watched the surface with a tight chest. The ocean above the platform now bulged higher than ever. Waves broke in strange lines, pulled sideways by forces they did not yet fully measure. We're getting close to the docking point, she said into the shared channel. Acoustic flashes between the trench city and the surface city have increased. It feels like a countdown. They had only one chance to try something larger. Catherine and her team designed a new signal over many sleepless nights. Not a brute command, not a scream, but a careful phrase built from the little they had learned. It will have 3 parts, she explained to Sophia and Eric. First, a clear ID. Local surface minds present. We build that by copying the gentle pattern that passed between Naomi and the vault. Second, a status share. We feed back some of the network's own current readings, so it knows we see what it sees. Third, a request. A small, repeated suggestion to slow the final meters of the rise and spread any added stress over a slightly longer time. Will it listen? Eric asked. I don't know, Catherine said, but we have to try. If we can stretch the last phase of this docking even a little, we may avoid sharp jumps in quakes or sudden current shifts. Sophia stared at the draft signal on her screen. It was strange and beautiful, like a song written in numbers, base 2.7-second pulses, small gentle waves on top, soft double flickers at key points. There is a risk, Sophia said. If we misshape the pattern, the system could see it as damage or attack. It might harden its fields or even speed up to protect itself. I've thought about that, Catherine said. That's why we are not using anything like the emergency spikes that woke the vault so hard. This is closer to a question than a command. If the network does not like it, we hope it will ignore us. And if it doesn't ignore us, Eric asked, then we learn very fast what kind of neighbor this second layer is, Catherine replied, because we will have its full attention. They chose 3 transmission sites, one in each ocean, near key seabed machines that were known to feed the rising cities. Smaller copies of the main test cage were lowered to the seafloor by ships and subs. At the same time, a weak version of the signal would be sent in radio and low-frequency magnetic waves from ground stations and a relay satellite, so that the network would sense the same phrase in several forms at once. If this is a nervous system, Catherine said, we are poking it gently in several places and saying the same thing each time. That should make it easier for it to notice the pattern. The time came just as the Pacific City crowns broke into a stronger glow. From orbit, Eric saw the cyan light bleed up through the last few hundred meters of water like a rising sun under the sea. All 3 crowns have increased output by 20%, he said. They are syncing with something, maybe the Trench City link, maybe the other cities. This is our window. Catherine stood in the control room at NOAA, hand hovering over the start control. Around her, screens showed real-time quakes, stresses, magnetic flow, sea level. Every team was at their station. Final checks, she said. Transmission power, 5% of local machine output, a tech replied. Spread across acoustic and magnetic channels, well under any level that caused issues in tests. Alignment with current network pattern. We phase locked to the latest readings from Pacific, Atlantic, Indian crowns and the vault, another said. Our base timing is exact. Overlays sit within safe margins. Sophia, Catherine asked. Pacific cage ready, Sophia said. We're lined up next to the main feeder machine under the platform shadow. My crew is braced and watching. Eric? I have eyes on everything from up here, he said. If the network flinches, he'll see it. Catherine looked at the main clock. For a moment, she thought of simple things. Her parents' old house in Boston, now behind a seawall, the students she had taught, Naomi still under care after Vostok, slowly healing. All of them were inside this experiment, even if they never knew. We begin on my mark, she said. 3, 2, 1, send. The signal left in silence. From the Pacific cage, the Indian cage, the Atlantic cage, and the ground stations, the same shaped waves slid into stone, water, and field. The 2.7-second rhythm matched the network's own, like hands joining in time. The soft extra curves added their small, careful hello. For a few heartbeats, nothing changed. Then the seabed machines near each cage shifted at once. Local outputs rising by 3%, a tech said. Patterns matching our additions. They're copying us. On Sophia's screens, the machine beside their cage brightened in cyan. Its pulse gained a small extra bump at the same place where their signal put a bump. "It's mirroring," she said. It heard the phrase and is repeating part of it down the line. Eric saw the effect spread. Along tectonic lines, machine after machine took on that small extra bump. Waves of it moved under the Pacific, the Indian, the Atlantic, like a subtle new accent added to a familiar speech. "The pattern is going global," he said. "Vault, cities, deep machines. It's everywhere in under a minute." Catherine watched the crowns. All three rising city crowns changed their light. The pale cyan beams grew steadier, less flicker, more smooth. On her monitor, the base pulse stayed at 2.7 seconds, but a new tiny hitch appeared in the same place as their request. "The cities heard us," she whispered, but did they understand? She checked the rise rates. Before the signal, each city had been climbing at exactly 12 meters per hour. That number had not changed since day one. Now the readout ticked to 1198. "Check that," she said sharply. "Is that real?" "Confirming from multiple sources," Eric said. "Laser altimetry, pressure changes, sonar. All three cities have lowered speed by about 0.02 meters per hour. That's tiny," someone said. "It's also the first time that number has moved at all," Catherine replied. "And it moved right after we asked." For the next hour they watched in tense silence. The rise rate stayed at 11.98. No further drop, but no return to 12. Quakes stayed low. Stress graphs showed slightly smoother curves with fewer sharp spikes. "We didn't stop them," Sophia said, "but we bent the line a little." "We proved two things," Catherine said. "They can hear us, and they are willing to adjust within some limit. That is enough to matter over months and years." Eric frowned at his magnetic maps. "There's something else," he said. "The field lines over the Pacific are reshaping faster now, into a more even spread. It's like the network used our request as an excuse to tune its own layout more gently." In the days that followed, a strange calm settled over the data. The cities kept rising, but a fraction slower. Small stress releases, tiny quakes and harmless shifts, spread out along plates instead of building into larger bangs. The cyan crowns brightened to a steady, strong glow, no longer flickering like struggling lights. Catherine, Sophia, and Eric spent long hours staring at the global model. Little by little, the second layer's shape became clear. The deep cities under trenches formed anchors, locking into regions where plates sank. The surface cities formed caps above major basins, seabed machines stitched between them, guiding force. The volt pulsed at the poles, tying into the field. "This is not half-finished work," Sophia said. "This is a full shell waking from sleep." Catherine nodded. "A second Earth wrapped around the first," she said. "Not a new planet, but a designed layer that has its own rules and goals." "And now it knows we exist," Eric added. "We didn't just listen. We spoke. That changes our role." On a clear night, as the Pacific ship rode slow swells, Sophia stood at the rail with a small group of crew. The stars above were sharp. The water below seemed almost to glow from within. Suddenly, the sea ahead rose and fell as a wide, smooth disk broke the surface. The Pacific city had reached its first stable height. Water sheeted off its sides in long waterfalls rushing back into the sea. The circle was huge, a flat plain of smooth, pale material stretching to the horizon from their point of view. At its center, a tall crown of crystal towers stood, shining with a calm cyan light that reached into the sky. Sophia felt her throat tighten. "We're looking at land made by hands that died before our oldest stories," she said. From orbit, Eric watched all three oceans. The Atlantic and Indian cities also reached the surface within minutes of the Pacific. Their crowns rose into air, glowing like three steady stars, low on Earth's limb. On his sensors, the phase-shifted structural fields adjusted. The walls stayed untouchable to weapons, but at the crowns something relaxed. The fields there softened, as if expecting contact. "They're opening interfaces," he said. "Not doors exactly, but places where we might touch without passing through." In Washington, Catherine stood in front of a giant wall showing all three new islands. Global news feeds were full of images, white shining disks in blue seas, crowned with alien spires. People everywhere stopped to watch. In streets, in homes, on phones. Her models updated one last time. Day length had shifted by an amount small enough that only atomic clocks could feel it, but it was changed all the same. The planet's rotation axis wobbled a little less, as if the new mass had steadied it. Long-term stress projections showed smoother curves. The second layer had taken its first full shape. "We are past the point of being just observers," she said quietly into the open channel to Sophia and Eric. "These cities, these machines, this vault, they form a living system around our world. It steers things we barely noticed before, and now it knows we are here and can speak, even if only a few words." On the deck, Sophia watched the cyan crown flicker in a new pattern. It was not the base 2.7-second pulse. It was more complex, like a question. "Are you seeing this?" she asked. "Yes," Eric said. "It's not like any of our test phrases. This is new." In the lab, Catherine recorded the pattern and overlaid it with their last sent signal. Her heart raced. "It's answering," she said, "not just adjusting. It is sending something built in response to us." She did not know yet if that something was a welcome, a test, or a warning, but she knew its meaning was not small. She looked up at the glowing rings on the world map. 3 cities on the seas, a vault under the ice, deep machines humming in stone. "We wanted to measure Earth," she said, more to herself than to the room, "to model it, to keep it stable. Now we see that an older mind has been doing that all along, hidden under the water." She placed her hand on the glass of the display, above the glowing Pacific disk. "We are in dialogue now," she said, "with a planetary machine that may decide what kind of future we are allowed to have. And for the first time, it is listening back, outside, across 3 oceans." The cyan crowns hummed in sync, sending their strange, steady light into the night, as a second Earth settled into place around the first. The dome over the Pacific city looked thin as glass, but every sensor said it was not. From the deck of her ship, Sofia Alvarez stared up at it. It hung over the cyan crown like a half bubble of light, about 500 meters above the city's center. In daylight, it was barely there, just a faint shimmer. At dusk, it glowed soft cyan, pulsing in time with the platform below. Her crew stood in a loose group beside her. No one spoke for a while. "It's lower today," the helmsman said at last. "Yesterday it sat at 600 meters. Now it's 500, maybe a little less. It wants us to notice," Sophia said, "or to reach it." In orbit, Eric Donovan watched the same dome from above. On his thermal feed, it was cooler than the air around it, a thin, cool shell. Radar showed a clear boundary. Waves bent around it instead of bouncing off. "That field is not hard-wall phase like the city," he told Catherine over the link. "It's more like a filter. High-energy particles pass through. Slow, ordered matter would feel something. An interface," Catherine said in the NOAA lab. "Not a shield." She stood in front of a wall of live data, pulses from the seabed machines, light from the crowns, signals from the Antarctic vault, traces from the 3 domes above each ocean, city. Each dome carried the same base 2.7-second beat, but the shapes above it were different from anything they had seen so far. Short, complex bursts, then long empty spaces, as if the network was sending test phrases and waiting. "They're using the domes as mouths," May said from her station, "or ears. They send a shape, then listen for a reply that is not just a pulse. Like not just a signal," Sophia said, hearing this, but maybe a physical contact. The idea had been growing for days. The second layer had heard their pulses. It had copied them and changed itself. It had made big, slow shifts to answer their pain maps. Now it had built 3 gentle fields above its crowns. It was hard not to see that as an invitation. "What happens if we send a drone into that dome?" a Navy planner had asked in a meeting. "Probably nothing," a physicist had answered. "Or it might get pushed back, or it might pass through and record field data we've never seen." "And what if we send a person?" the planner had said, half joking. No one had laughed. Now in the lab, Catherine looked from the domes on her screen to Naomi's heartbeat trace in the corner. Human contact had woken the Antarctic vault. Human signals had bent the rise of the cities. The network seemed tuned to life, not just machines. "If this is really an interface," she said, "it might be shaped for minds. Sensors will help, but sooner or later we may need a human inside that field." Sophia heard that over the open channel and knew what Catherine was leading to. Her stomach tightened. "You're thinking of Naomi," Sophia said. "Her heart, her pattern." "Yes," Catherine said. "Naomi is still not strong enough to go near a field like this. Her nervous system took a hard hit under Vostok, but we can learn from her link. We can train someone, prepare them, pick a person whose natural rhythms are close and can handle it." Long turned in her chair. "We have thousands of hours of Naomi's heartbeat and brainwave data," she said. "We've built them into our signal language. We can also look for others whose rhythms match some of those shapes." "Are you asking for volunteers?" Eric asked. "To walk into a field of unknown physics over an alien city?" Catherine did not flinch. "I'm saying the network has taken steps toward us. If we never take a step toward it, we waste the only chance we may ever have to shape what it does next. But this has to be a choice, not an order." The world moved fast. News of the dome spread within hours. Images ran on every channel, shining disks in 3 oceans, each with a faint cyan bubble over its center. People argued on screens and in streets. Some said, "Stay away. We've done enough. Let the second layer do what it wants." Others said, "Go. Learn. If we turn our backs now, we give up any say in the future." In the end, the decision came down to a small group. They would send a person toward the Pacific Dome, accompanied by drones and wrapped in sensors. That person would not be a soldier, not a politician. It would be a scientist with training in signal language and a body trained to match the network's safer patterns. They chose Sophia. She argued at first. "Catherine knows the models better," she said. "Naomi has the closest link. Catherine has to watch the whole system." Eric told her, "Naomi is still healing. And you're already here. You know the seabed machines, the trench city, the crowns. Your heart profile is a safe partial match to Naomi's Vostok rhythm. You also keep your head when things get strange." Sophia stared at the medical report. Her heart did in fact show a natural resting rhythm close to the network's base beat. Her brainwaves in calm focus lined up with some of the vault's explored patterns. "You can say no," Catherine told her on a private link. "We'll find someone else. I will never blame you if you choose not to step into that field." Sophia thought of the cities below, rising whether anyone liked it or not. She thought of millions of people who would live with the slow changes the second layer was planning. She thought of Naomi in a hospital bed, carrying the marks of the first contact. "If there is even a small chance I can push this thing a little toward a kinder line," she said, "I have to try." She signed. Preparation took 3 days. Doctors checked her heart and nerves again and again. Engineers fit her with a slim suit full of sensors and field buffers. It would not stop the dome's phase field if it turned dangerous, but it would let Catherine and her team read every pulse that moved through Sophia's body. May and the signal team built a support pattern, a gentle, repeating signal that would play through Sophia's suit, helping her heart and brain lock to the safe parts of the network's rhythm. "We're not forcing you," May said. "Think of it as a soft metronome, like music in your ears. You can follow it or ignore it." Sophia laughed once. "I used to play piano badly as a kid," she said. "I'm used to fighting the metronome." On the day, the Pacific was flat and gray. The huge white disk of the city filled the horizon ahead, its edge pouring waterfalls back into the sea. The cyan crown shone like a small sun in the middle, and above it the dome waited. The ship held position at the city's rim. A small aircraft, more like a large drone with seats, sat ready on the aft deck. "Final suit check," a tech said, fastening the last seals. "Sensors live, signal feed ready, heart rate steady." Catherine's face filled Sophia's wrist screen. "We'll be with you every second," she said. "If the field pushes you back, do not fight it. If you feel pain beyond steady pressure, say the word and we pull you away." Eric chimed in from orbit. "I have dedicated satellites watching only you," he said. "If the network even blinks funny near that dome, You'll see it. Sophia took a slow breath. The support pattern hummed in her ear. A soft, steady 2.7-second beat with small, calming waves in between. Her heart fell in with it almost without trying. "Okay," she said. "Let's go see what an ancient planet shell wants to say." The small craft lifted off and skimmed over the water, then over the city's bright surface. From above, Sophia saw details cameras had only hinted at. Wide radial channels carved into the disk, towers along the rim, smaller spires like organ pipes around the crown. As they neared the center, the dome's shimmer grew clearer. It was not a perfect half-sphere. It bent slightly toward them on this side, like a hand held out. Crossing into field zone in 30 seconds, the pilot said. In the lab, Catherine watched Sophia's heartbeat and brain waves. They stayed close to the support pattern, calm but alert. "Signal level rising," May said. "The dome is sending more power as she gets closer. The pattern is structured, but not like the grid signals. It's simpler, maybe tuned to human senses." At 10 seconds out, the small craft slowed, field density increasing, the pilot said. "It's like flying into thick air. Controls are sluggish." "Take us to hover just under the dome edge," Sophia said. "Then hold." They stopped a few dozen meters below the glowing shell. Up close, it looked like a surface of slow water, ripples of cyan moving across it in rings. There were no visible doors or breaks. Sophia keyed her mic. "Catherine, I'm going to step onto the crown. The field seems to want contact above the central spires. Not from the air." Catherine's hand tightened on the console, but she did not argue. "Stay on the outer ring first," she said. "Test the surface. If it reacts badly, we back off." The craft touched down near the edge of the crown. The material under its skids was firm, not slick. It felt like stone and glass mixed. Sophia stepped out. Her boots met the alien surface with a small, solid tap. No shock, no hum. Just a faint sense of being watched, even though there were no eyes. She walked slowly toward the center. Each step brought a slight tug in her chest, like mild gravity changes. Her heartbeat trace on Catherine's screen wobbled but stayed close to the support rhythm. The dome overhead brightened. When she reached the ring of crystal spires around the very center, she stopped. The nearest spire was taller than a house. Its sides were smooth, glowing from within. Faint symbols or patterns moved on its surface, but they changed too fast to follow. "The field is strongest here," May said in her ear. "You're at the interface point." The dome above her pulsed once, bright, then dim. Sophia took a breath. "If you really are listening," she said aloud, even though she knew the network cared more about fields than words. "I am Sophia Alvarez. I come from the surface, from a young people living on your crust. We have felt what you do. We have tried to speak back. We are here in good faith." Catherine sent the same message as a signal, pulsed through Sophia's suit, a short phrase in their crude signal language that meant local minds present, peaceful. The dome's glow shifted. It lowered. Very slowly, the cyan shell sank until its lowest arc touched the tops of the central spires. Then, with no sound, it dipped lower and brushed the space around Sophia. Her suit sensors spiked. "Field contact," May said. "Phase level within expected safe range." It's tuning to her. Sophia felt it like a warm pressure on her skin, then a gentle vibration in her bones. Her vision blurred for a moment, then cleared. For an instant, she saw double, the city as her eyes saw it, and faint lines of light laid over it, like nerves, long. Her heartbeat synced fully to the 2.7-second pulse without effort. Her thoughts felt slightly slowed, but clear. Catherine watched in awe. "The dome is adjusting its signal to match her nervous system," she said. "Not forcing, aligning." "Sophia," Eric said, "if at any point you feel like you're losing yourself, say so." Sophia nodded, though she knew he could not see. "I feel held," she said. "Not crushed, like being in a strong current. You can still swim in." Then something new happened. A pattern appeared across her visual field that was not from her suit or any screen. Lines of cyan drew themselves in the air before her, simple shapes at first. Circles, waves, spikes, signal language, but inside her sight. It's sending symbols right into her visual cortex, May said, watching the brain scans. Careful, careful. Sophia focused on the first shape, a steady circle with a tiny pulse at its edge. It shifted to a simple map of Earth, then to 3 glowing spots in the oceans, then to lines around the planet. It's showing me itself, Sophia said, the second layer around Earth. The image grew more detailed. She saw the seabed machines as dots along lines, the deep trench cities as heavy arcs, the surface cities as disks. She saw the Antarctic vault as a bright node at the bottom of the globe. Then, slowly, other shapes appeared woven through the first clouds, currents, living things, blue layers for oceans full of fish, green and brown patches for forests and soil, tiny moving dots for animals and humans. The Lemurian shell did not sit apart. It tangled with everything. It sees life, Catherine murmured, reading the shared stream. It tracks us, not just rock. A new shape appeared, a long curve showing climate swings over millions of years, ice ages, hot ages, sudden spikes from volcanoes. Over that, a smoother curve appeared, like a hand laid gently on top. The message was clear. It's saying, "I smooth this," Sophia translated aloud. It shows big jumps, then its own curve making them softer. Then another thin curve appeared, very short, spiking up sharply at the end. Human industry, carbon, cities. The second layer's curve did not match it yet. It bent slowly toward it. "It didn't plan for us," Catherine said. "At least not exactly. Our spike is too steep and too fast." More shapes flowed past. Sophia saw a flash of Lemurian cities long ago, on raised platforms and in deep basins, bathed in cyan light. She saw storms around them, huge, controlled, directed away from certain regions and into empty seas. She saw vast fields of life, calm oceans, slow-moving plates. Then she saw changes, the Lemurian lights dimming, some cities sinking back underwater, the vault closing, a long sleep. The message was not detailed history. It was more like mood. They had built the shell, used it, then stepped away, leaving it to run in low-power mode, waiting for new input. "Why did they leave?" Sophia asked softly, though she knew the network might not answer that. A strange flicker passed through the shapes, a wide dark band, then small flares rising elsewhere on the globe. The sense was of risk spread too thin, of too much control, then a pulling back. It's showing overreach, May guessed, then retreat, like a feedback loop that went too far. Now Sophia saw the present again. The human spike, the second layer rising to meet it. The two curves not aligned, but trying to bend toward each other. A new shape appeared, a small line, very short, linking the Lemurian curve and the human spike. Naomi's heartbeat trace fit into that spot perfectly. Then, next to it, another small line, Sophia's current pattern, live. She understood. "You left a way to listen," she said quietly, in case new minds rose up. "You waited for a heartbeat, close enough to your rhythm." The dome's pressure grew warmer. New symbols formed, a spiral that unfurled, then 3 small loops inside it. Choice points. Catherine watched the trace from the dome and overlaid their own models. "It's offering paths," she said, "at least 3. Sophia spoke slowly, half to the dome, half to her friends. "I see 3 lines of change," she said. "First, strong control. The second layer takes tight hold. Quakes small, storms gentle, sea level guided exactly. But the human spike, our heat, our chaos gets cut hard. Population falls, strict limits. We live safe, but inside tight walls." She swallowed. The image for that path felt cold, even if it was stable. "Second, loose control," she went on. "The second layer pulls back. It smooths only the worst shocks. We keep more freedom. Our spike stays high. More storms, some big quakes, more random pain. We take more risk on ourselves. The planet stays wilder." Her chest hurt a little as she watched that line. More cities flooded, more farms moved, more people lost or forced to wander. "Third," she frowned. This one was less clear. The symbols twisted, tangled. Third is shared control, she said. The second layer opens enough for us to learn more signal language and send more detailed maps. It keeps smoothing the very long cycles. We agree to change some of what we do, how we use energy, how many of us, how we spread out to fit its slow rules. In return, it shapes its own moves to fit our pain maps better. Neither side gets full comfort, both give and take. In the lab, silence held for a long moment. It's offering a kind of contract, Catherine said, not in words. In physics, in allowed ranges of stress and flow. Do we get to choose? Eric asked. The symbols on Sophia's inner sight shifted again. She saw many small dots on the human side, not just her. Each dot had a faint line to the second layer. The lines thickened where people listened and spoke back. The overall shape changed as the dots moved. Long. It won't take one choice from me, or from any leader, Sophia said. It will read what many of us do over time, how we send signals, how we change or don't. It will keep adjusting. Then a single bright dot flared, Naomi's heartbeat. Then another, Sophia's. Then many dimmer dots. Others who had been close to signals, who had worked with the data, who had watched and cared. The sense was clear enough. But first, Sophia said, it needs a seed, a clear, spoken intent from those who understand it best. A starting push on the third path, or it will default to the first or second by its own old rules. You're its first counsel, May whispered. You, Catherine, Eric, Naomi, and the rest of us around the edges. The dome's field eased a little, as if it agreed. Sophia closed her eyes. Shapes still danced behind her lids, but she forced herself to think with her own mind, not just follow. Full strong control would likely save more lives, in the short term, but it would crush human freedom and change into something like managed pets. Loose control would keep freedom, but at the cost of huge, unfair suffering, mostly for the weakest. Shared control was messy, unstable, open to failure. It also was the only path that treated humans as something other than problem or threat. Catherine, she said softly, you always said we needed to think in longer time than elections. Yes, Catherine replied, voice rough, but not to throw away the people alive now. If we choose shared control, Sophia said, we're choosing work, decades of walking between what we want and what the planet can take. With this thing as partner, we'll fight among ourselves. We'll make mistakes, but we won't be erased. Catherine closed her eyes for a moment in the lab. She thought of old coastlines, new maps, her students, Naomi, her own life spent reading plates in storms. Long 5, her one grandchildren to a shell that sees them only as stress points to flatten, she said. And I can't shrug and say, let the dice fall when I know there is a mind here that can help. She took a breath. I choose shared control, she said, with teeth, with honest limits, with us as noisy, stubborn partners. In orbit, Eric looked down at the glowing domes and the spinning world beneath. I signed up to watch and defend, he said. I never thought I'd be voting on how a planet thinks, but I trust both of you, and I've seen enough storms and quakes from up here to know doing nothing is its own choice. He nodded, though no one could see. In the hospital wing in Boston where Naomi lay, still recovering, doctors watched her monitors in surprise. Her heart rate had steadied into a calm, strong pattern. Brain activity rose in a gentle wave. She whispered a single word. Yes. Around the world, other small lights flared in data. People who turned on feeds to watch the signals, who learned the simple 2.7-second beat and tapped it on tables, who sent their own tiny, clumsy pulses with home-built gear. Most did not understand the full stakes, but they reached anyway. The dome over Sophia brightened. It wrapped a little closer, not crushing, but linking. For a moment, she felt herself expand, not in body, but in sense. She felt the slow grind of plates, the cool pull of deep currents, the faint drag of the moon. She felt the 3 cities, their crowns humming. She felt millions of tiny points of human heat and thought, bright as sparks. Then it shrank again, letting her be a single person inside a suit on a shining disk. The symbols before her eyes simplified. A steady curve appeared, somewhere between the tight control line and the wild line. It wobbled, leaving space for error and play. Small arrows showed movement both ways. From the second layer to humans. From humans to the second layer. Agreement. Catherine saw the echo in the global signal. Across the network, the base beat stayed the same, but the shapes above it shifted into a new, repeating pattern. A contract marker formed. 2 linked loops, one slightly larger, one smaller, turning together. Stress maps updated. Some sharp peaks faded further. In other places, gentle waves grew, signaling that old, unfair balances would be nudged over time. Long-range climate models bent a little toward fairness. A bit more relief for crowded delta coasts. A bit more challenge for those who had used the most energy. It's begun, May said. The third path is live. The domes over the 3 cities steadied into fixed heights. Their fields stayed soft, open for future contact. The cities themselves kept rising, slowly, toward their full design height. The trench cities locked more firmly under them, closing the circuits. The second Earth had not taken over. It had not gone back to sleep. It had shifted into a new state, awake with a new partner at its edge. Sophia felt the dome's presence fade back a little. The pressure on her bones eased. The shapes in her sight thinned, leaving only a faint cyan afterimage. "You okay?" Eric asked quickly. She laughed, breathless. "I feel like I just had the world's longest conversation in a language I barely speak," she said. Long conversation. Ongfors far, kadars brungoli. We go on that for loss. Ours is open a place. "Come back in," she said. "That's enough hero work for one day." The small craft lifted off from the crown and flew back to the ship. As it rose, Sophia looked down at the city. It did not look less strange. It still shone with alien geometry, channels and towers and crystal cores. But now, to her, it also looked like a giant, careful tool built long ago and left waiting. Waiting not just to shape rock and sea, but to listen. Later, back in the lab, after tests and checks and a long sleep, Catherine stood once more before the big globe. The second layer sat around it like a faint shell of light. New data points popped up as small projects began. Tiny signal stations on quiet coasts, joint labs at the city rims, slow, careful changes in how power grids and farms and cities worked, built to stay inside the new limits they had agreed to. "We still don't know what happened to the Lemurians," Eric said over a calmer, almost friendly link from orbit. "We don't know if they vanished in a mistake or simply moved on." "No," Catherine said, "but we know what they left us. A chance not to be only victims of cycles we don't control, and a warning not to grab so hard we break ourselves." May pointed at a small blip on the Antarctic data. "The vault sent another pattern," she said. "It's quiet, simple. Looks like a greeting." Catherine listened to the 2.7-second beat and the small, gentle curve above it. Sophia, watching from a rest chair with a blanket over her knees, tapped the rhythm on the armrest. In towns and cities and ships, other people tapped it too, not even knowing all of its meaning yet, just feeling its calm. "The second Earth is no longer hidden," Catherine said. "We live inside its reach. It lives inside our choices. From now on, our future isn't just written in stone and ice and air. It's written in signals we send and answer." She touched the globe lightly. "We asked for a say," she said. "Now we have it. That means the hard part isn't over. It's just starting." Outside, 3 vast cities stood in 3 oceans, their crowns glowing steady cyan under soft domes. Deep below, trench structures hummed. Along the plates, seabed machines pulsed. Under the Antarctic ice, the vault shone. Around and through it all, a young species and an ancient network shared. A new, fragile language, beginning, slowly, to decide together what kind of world this would be.